Hello friends, welcome to our channel Mechanical Motivator. In this video, we will be seeing problems on flywheel. So first problem is the turning moment diagram for a multi-cylinder engine has been drawn to a scale of 1 millimeter is equal to 600 Newton meter vertically. So this is the scale and 1 millimeter is equal to 300 degree horizontally. So turning moment diagram, we need to plot between y-axis as torque value, and x-axis will be plotting with crank angle. The intercepted areas between the output torque curve and the main resistance lines are taken in the order from one end as follows. So plus 52 minus 124, so on till 107 millimeters square. That is, starting will be 52 positive and minus 124 is negative, and 92 is positive and 140 is negative. Likewise, the curve will be keep on fluctuating. When the engine is running at a speed of 600 rpm, so omega is equal to n is equal to 600 rpm. So omega will be equal to 2 pi n by 60. So we will be getting the in terms of radian per second. If the total fluctuation of speed is not to exceed plus or minus 1.5% of mean, that is nothing but plus 1.5 and minus of minus 1.5. Actually, omega will be writing as omega 1 minus omega 2. So plus 1.5 minus of minus 1.5 will be become plus 1.5. So totally it will be 3%. So we'll be seeing here. Actually, since the fluctuation of energy not to exceed the mean speed, that is the fluctuation of the speed is not to exceed plus or minus 1.4% of the mean speed, means omega 1 minus omega 2 will be 3% of omega. This 3% is plus 1.5 minus of minus 1.5. So automatically it will be become 3%. So finally what will be 3%, we can write as 0.03. So coefficient of fluctuation of speed, we know CS is the coefficient of fluctuation of speed, is nothing but omega 1 minus omega 2 by omega. So we will be getting CS, coefficient of fluctuation value, as 0.03. Find the necessary mass of the flywheel if radius is 0.5 meters. So radius they have given. So this diagram is easy to plot. We know how to plot it. Next we're going to go for the scaling. The scaling is they have given clearly that 1 millimeter is equal to 600 Newton meter and crank angle is 1 millimeter is equal to 3 degree. So convert this degree into radians. So 3 into pi by 180. So you'll be getting pi by 60 radians. So in this diagram, everything are in terms of area, which is nothing but millimeter square. So 1 millimeter square on the turning moment diagram will be just multiply the turning moment scale and the crank angle. So turning moment scale is 600 and crank angle is pi by 60. So you'll be getting 31.4 Newton meter. So 1 millimeter square on the turning moment diagram will be equal to 31.42. So we'll be determining the areas, and finally we'll be finding maximum fluctuation energy, that is nothing but maximum minus minimum. In that we'll be getting a value as 172 millimeter square. Actually in turning moment diagram we will be having in terms of millimeter square only. So finally we will be getting 172 millimeter square. To convert that millimeter square in Newton meter only, we are doing these things for scaling. So finally just multiply that millimeter square, instead of millimeter square 31.42, in order to get in terms of Newton meter. So next we will be determining the total, how much energy involved in the turning moment. So let the total energy at A will be E. So assume total energy at A will be E, and if B means E, 52 is positive, so E plus 52. So energy at B will be E plus 52. Next is C point. So here we are having negative, minus 125. So whatever values you got, you just write as it is. Energy at C is E plus 52 minus 124, since it's negative. So you'll be getting E minus 72. Energy at D point, now positive, plus 92. So whatever values you got, E minus 72 plus 92. So you will be getting E plus 20. So likewise, energy at E. So energy at E means now we are having negative value, minus 140. So E plus 20 minus 140. Likewise, we will be doing step by step, and finally, energy at G we have got as E minus 107. So E minus 107. If energy at H means E minus 107 plus 107. So finally, we will be having E only. If we get the energy, whatever energy we got at A, same energy means our calculation is correct. In this, we'll be having two values. One will be maximum and one will be minimum. The maximum is E plus 52 and minimum is E minus 122. E minus 120. So just have a mark of it. The total maximum fluctuation of energy is nothing but del E is equal to maximum energy minus minimum energy. So E plus 52 minus E minus of E minus 120. So finally we'll be getting 172 millimeter square in terms of area, right? So to convert it to Newton meter, we use the scale value as 31.42. We need to find the mass of the flywheel. So for that, we know the fluctuation for maximum fluctuation of energy formula. So del E is equal to I omega square Cs. So I is the mass moment of inertia. For that we can write as mk square or mr square. So instead of radius of gyration, we are having the value as r only. So that is the radius. So we can write as, instead of k, we can write r. For this case is possible and applicable only for the flywheel rim alone. So mr square, r value we know, omega square value, omega value we know, Cs value we know. Only m is the unknown. So determine, keep the m alone on one side and take everything to the right hand side, and you will be getting an answer as 183 kg. In next problem is turning moment. Yeah. Turning moment diagram for a 4-stroke gas engine may be assumed for simplicity to represent by 4 triangles. So previous case we saw in the form of waveform, right? In this sum we will be having in the form of triangles from line of zero pressure. I mean, now they have given 4 strokes: suction, compression, expansion, exhaust, and all the 4 values they have given in the question. Each meter square, that is the scaling value, each meter square of area represents 3 meganewton meter of energy. So this is the scale factor. Assuming the resisting torque to be uniform, find the mass of the rim of the flywheel required to keep the speed between 202 and 198 rpm. So N1 and N2 values we have got. The mean radius of the rim is 1.2 meters. So R is 1.2. We got the area for the 4 strokes: A1, A2, A3, A4 values. N1 and N2 are the 2 different speed, and R is the radius. So the turning moment crank angle diagram for 4-stroke engine is shown here. So the areas below the zero line, will be negative, and whatever areas above the zero line is positive. So expansion stroke alone positive, and compression, suction, and exhaust are all negative. So net area is A3 alone. This A3 alone positive, minus remaining thing, everything it's negative only. So A3 minus summation of A1 plus A2 plus A4, and finally we'll be getting a net area as 4 into 10 power minus 3 meters square. We know the energy scale. 1 meter square is equal to 3 meganewton meter. So convert, mega means 10 power 6. So 3 into 10 power 6 Newton meter. So net work done per cycle is net area into the energy scale. So net area is 4 10 power minus 3. Energy scale is 3 into 10 power 6. We will be getting the work done per cycle as 12 into 10 power 3 Newton meter. Now we know the work done per cycle. This is the another formula for work done per cycle is T mean into 4 pi. So this we know already. So in this already equation 1 left hand side is work done, and equation 2 left hand side is work done. So left hand sides are equal. So now we are going to equate equation 1 and 2 with the right hand sides. So finally keep the T mean. T mean is nothing but FG value. T mean, see this diagram. This diagram is also drawing is very easy. Turning moment on x axis and y axis, and crank angle on the x-axis. So suction, compression, and exhaust, and finally suction, compression, expansion, and finally exhaust. And we will be getting a crank angle as 4 pi. T mean is Fg and T max is Ag. So T mean is Fg. So just equate equation 1 and 2 and the right hand sides around. So automatically 12 10 power 3 divided by 4 pi, you will be getting 955 Newton meter. So Fg value is 955 meter. Next is work done during expansion stroke, that is A3 into energy scale. A3 value we know and energy scale we know, and we will be getting a value as 20.4 10 power 3 Newton meter. So coming back to the diagram. So now we're going to see work done for the expansion stroke. So work done for expansion stroke, one equation will be getting, and second, work done during expansion stroke. Take this triangle ABC. So automatically half into base into height. So half into BC into AG. So half into BC is nothing but pi. 3 pi minus 2 pi, we will be getting pi. So BC is pi, and AG value we need to determine. AG is the height we need to determine. So keep as it is. Now we equate equation 3 and 4. In this, left hand sides are equal and right hand sides will be equating. Finally, why we are equating is we need to determine the value of AG. So try to determine AG value. So if you equate means keep AG alone on the left hand side and take everything to the right hand side. And finally, you will be getting the value for AG. XS torque. So XS torque is, see, this is the excess, so this is the excess torque, right? So AF is the excess torque. So AG minus FG. So if you want to find AF means AG minus FG, you will be determining the TXS. Now we need to determine the fluctuation, maximum fluctuation energy. So del E for this triangle ADE. For that we need to have the value of DE. We haven't know that. We need to find that. For that, what we're going to do is we're going to compare the two similar isosceles triangle, that is triangle ADE and ABC. If you compare means DE divided by BC, DE divided by BC, AF divided by AG. AF divided by AG. Keep DE around left hand side and take everything to right hand side, and you know all the values. Finally, you will be getting an answer as 2.9 radians for DE, because Newton meter get cancelled and pi is in terms of radians. And finally, we're going to determine the maximum fluctuation energy. So del E is equal to area of triangle ADE, half into DE into AF, half into DE base, and AF is the height. Now we got all the values. DE value we know, AF value we know. So just substitute and you'll be getting the answer. For finding the mass of the rim of the flywheel, M is the mass of the rim of the flywheel in terms of kg, and N is the mean speed. So we have got two different speed. One is maximum and another is minimum. So N1 plus N2 divided by 2. So you'll be getting the mean speed. So maximum fluctuation energy del E formula is, here what they have done is same, I omega square CS. So CS value we can actually, here what they done is omega, see here, omega means 2 pi n by 60. Omega is 2 pi n by 60. Omega square is there. Try to take the n square outside. And here CS value is nothing but n1 minus n2 divided by n. N1 minus CS we can write as n1 minus n2 divided by n into 2. Automatically this 2 and that 2 will be getting cancelled, and if you reduce means we'll be getting in this case pi square by 900. So don't get confused. Formula for del E is I omega square CS. I can be written as m r square. Omega can be written as 2 pi n by 60 whole square, and CS can be written as n1 minus n2 divided by n into 2. So if we reduce the equation means you'll be getting like this only. And finally substitute all the values and you'll be determining the mass value as 1381 kg. The next problem is a single cylinder, single acting 4-stroke gas engine develops 20 kilowatt. So power is equal to 20 kilowatt. So convert into watt, and RPM speed is 300 RPM. So KPN. The work done by the gases during the expansion stroke is 3 times the work done on the gases on the compression stroke. So we will be using this for solving the problem. Just have a mark of it. The work done during suction and exhaust strokes are negligible. So suction and exhaust we can neglect. The total fluctuation of speed is not to exceed plus or minus 2% of mean speed. So automatically plus or minus 2 means 4% will be getting. 4% of mean speed will be getting. And the turning moment diagram during compression and expansion is assumed to be triangle. So they have given a hint. Diagram will be having triangular shape. Find the moment of inertia of the flywheel. So power we know. Power is equal to 20 kilowatt. So 20 into 10 power 3 watt. So n we know. So once you know n means we can easily calculate the omega value. And since the fluctuation of energy, as I already said, since the plus or minus 2% means, so omega 1 minus omega 2 is equal to 4% of omega mean speed. So automatically CS value is omega 1 minus omega 2 divided by omega. So 4%, right? So 4% can be written as 0.04. So next is we know the turning moment diagram for the four-stroke engine, which is shown in the diagram. And here the suction and compression is negligible, and we need to consider only compression and expansion. So expansion around positive, compression is negative. So here we need to know for four-stroke engine, so number of working strokes per cycle for two-stroke is capital N. For four-stroke is N capital N divided by 2. Capital N we know speed, divided by 2 means 150 we are getting. So work done per cycle is, the formula is power into 60 divided by number of strokes, number of working strokes per cycle. So finally we'll be getting work done per cycle as 8000 Newton meter. So this is the diagram. So y-axis on turning moment, x-axis on the crank, x-axis is the crank angle, and after drawing t-axis is nothing but AF is the t-axis, and T maximum is age. T maximum is age is the T maximum. So finally, what we're going to determine is, since the work done during suction and exhaust are negligible, therefore the net work done by the cycle during compression stroke. So expansion minus compression, work done during expansion minus work done during compression. Here they have given the hint as work done during expansion is 3 times of compression. So in order to you need to know the compression work done during compression, just bring the 3 downwards denominator. So finally we'll be having work done during expansion minus work done during expansion divided by 3. So finally 2/3 of work done during expansion we'll be having. Now what we're going to do is we're going to determine equating equation 1 and 2. So this is the equation 2 and this is the equation 1. Work done by the cycle is the equation 1 and work done by the cycle is the equation 2. So if we equate these two, the right hand sides will be equated. So finally we'll be getting 12,000 Newton meter. So work done during expansion stroke, that is work done during expansion stroke is area of triangle ABC. Area of triangle ABC. This is the expansion stroke. So half into base into height. Base is BC, which is nothing but pi, and height is AG. Finally you will be getting that is AG value. AG alone you keep on the left hand side and take everything to the right hand side. AG is the T maximum. So AG is the T max and FG is the T man and TXS is AF. So finally turning T mean is equal to T mean is nothing but FG. So T mean FG we can determine by work done per cycle divided by crank angle per cycle. Work done per cycle is 8000. We got here. Crank angle is 4 pi. So we can easily get the answer. We can also calculate by another formula also. That is power is equal to T mean into omega. So T mean if you want means power by omega. Power is 20 10 power 3. Omega is 31.42 and we can easily get 637. So any of these two methods we can follow. Excess turning moment is TXS. So AF is the TXS. AF is equal to AG minus FG. So both the values we know, we can easily calculate. Now we need to determine the maximum fluctuation energy del E for this triangle ADE. For that purpose, we need to know the value of DE as we saw earlier. For that, we're going to compare similar triangles. So DE by BC is equal to AF by AG. So keep DE alone left hand side and take everything to right hand side and determine the value of DE as 2.88 radian. So here we need to determine the fluctuation energy for the triangle ADE. So half into DE into AF. DE value we know, AF value we know. We can easily calculate the maximum fluctuation energy as 10,081 Newton meter. Now I is the mass moment of inertia. So maximum fluctuation of energy del E is equal to I omega square CS. Omega value we know, CS value we know, and del E just now we got. So it's very easy for us to calculate the I mass moment of inertia value. Actually it's mass moment of inertia, not moment of inertia, mass moment of inertia. So I value is 255.2 kg meter square. I hope so all the 3 problems are very clear for you. In case if you have any doubt means type in the comment section. Please do subscribe to my channel Mechanical Motivator and press the bell icon. Then only you will be getting all the videos which I upload. Thanks for watching this video. Have a great day.